Hi everyone. Let's solve today's daily challenge, that is find all anagrams in a string. So we are given two strings S and P and we have to return an array of all the start indices of P's anagrams in S. You may return the answer in any order. So what is an anagram? An anagram is a word or phrase formed by rearranging the letters of a different word or phrase, typically using all the original letters exactly once. So let's see. Let's first understand what an anagram means. So anagram of a given string, let's consider a string, right? Let's say this is the string that is given to us, ABC. So anagram is nothing but a string which contains all these characters, right, that are present inside of this string, and they might be arranged in a different fashion. For example, if I take BAC or CBA, right, or BCA, right? So all these have the characters present inside of this string, right, at most once, and also they are arranged in different manner, right? So we can say that BAC, CBA, and BCA, these are anagrams of ABC. So I hope what is an anagram, that is clear to you. So now let's move to the question. Let's see what the question given is. So in this question, what we have to do is we are given this string P, right? And we have to check whether the anagrams of this P exist in S or not, right? If they exist, we have to take an array, let's call it ans, and we have to take the start index of the anagram that is present inside of S, right? So let's see. So now in S, let's reverse. So from C, if we start, so we have to take the number of characters that are present inside of P, the length of P basically. So it is 3, so we will consider 3 characters. So while we consider 3 characters, we can see that CAB, the substring, it has all the characters present inside of P, right? But they are arranged in a different manner. So we can say that CAB is a anagram of P. So what we have to do in that case, we have to take the start index and we have to include it inside of our answer array, right? Similarly, we will take the next group of threes. So this is not an anagram, obviously, because it has other characters and it does not contain all the characters that are present inside of P. So this is not an anagram. So we will again take groups of 3 and move forward. So again, we can see that it is also not an anagram. So we'll keep doing this until we reach here, right? That is the part BCA. So we can clearly see that BCA has all the characters present inside of P arranged in a different manner. So we can say that BCA is an anagram of P. So what do we have to do? We have to take the start index of this anagram and we have to include inside of our answer. Then what we will do? We will traverse ahead. So again, taking groups of 3. So we will reach here at ACB. So this is also an anagram of ABC because it contains all the characters arranged in a different manner. So we have to take the starting index 12 and we have to append it inside of our answer array. And by the end of this string S, we have to find all these anagrams and we have to take their starting index and include it in our answer. And this is what we have to return, right? So I hope the question is clear to you. Now let's see how we will solve this question, right? So one approach that might come to your head is like, because the characters are arranged in a different manner, what we can do is we can sort this, and also we can take the substring of this S of size P length, and we will also sort this and we will compare these two, right? So for doing this, what you will be doing, you will be iterating inside of this S. Let's say its length is N and you will be having P, right? Let's say you sorted outside only. So while you traverse inside of this S, you will also be sorting that particular substring of size M, right? So the time complexity that you will be getting will be, for this for loop, that will be N, and for this sorting, that will be M log M. So if you see in the question, if you see the constraints given, so S length and P length can be between 3 raised power 3 into 10 raised power 4, right? So the upper bound of this you can say is n square log n, right? So this will give you TLE. So we cannot use this approach. So let's see what else we can do. How can we reduce this time complexity? So one thing that you can notice here is that we don't care about the order of the characters. All that matters is the frequency of the characters, right? All the characters present inside of P should also be present inside of the substring that we are considering in S, right? So it is the frequency of the character. So what we can do is we can create two frequency arrays, right? One for the substring of S and one for P, right? So let's call Si, that will be the frequency array for a particular substring of size M, and Pi, that will be having the frequency of characters present inside of P, right? So the length of this will be 26 and all the initial values will be 0, right? Then what we will do, first we will create for Pi, right? So what will it look like? This is 0, 1 up to 25, right? Wait, 0, 1, 2 and 3 up to 25 we will go, right? And initially it's 0, everything is 0. Now 0 represents, this is 2, 0 represents A, 1 represents B, 2 represents C. So basically at 0th index we will be storing the frequency of character A, right? At 1th index we will be storing the frequency of character B, and similarly up to Z we will be storing inside of this frequency array. So now let's see for this case what will Pi look like. So we have ABC, right? So Pi will look like 1, 1 and 1, right? Now for Si, what we will do, we will consider one substring, right, of size M. So we will start from the first position. We will take two iterators also, right? Okay, this let's call it left and let's call it right. So we have these two pointers, right, pointing to the particular substring, right? So we will take from left to right, we will consider the substring, and for this substring we will be creating this Si, right? So this Si for this case it will be similar to this, right? That is 1, 1 and 1 inside of this array. So this is what Si for this part looks like. Then what we will do, for each iteration we will check whether Si is equal to this Pi. So for this case we can see that Si will be equal to Pi, right? Because it is the frequency of the characters that should be same in both of the strings. So then we can say that yes, this is the answer, and we will include the left pointer inside of our answer array, right? Answer array, we will include the left pointer, that is 0. Now we will slide ahead, right? Move ahead, that is we will be moving to this part, right? So our left will be pointing here and our right will be pointing here. So before moving to this part, what we will be doing is we will be removing this left from this Si, right? Whatever is the frequency of this left character, we will decrease it by 1. So what we will be having here is we will have 0, 0 here, and we will include this right after incrementing it, that is G. So for G we will be going, and somewhere here we will be having G. So we will include G in our answer, in our Si, right? So we will keep doing this for each and every partition, right? So this approach is actually called sliding window, because we are sliding in this right minus left part, and that is what we call a window size, and we are sliding ahead, right? So this approach is called sliding window. So that is what we are using, and at each iteration we will be updating this Si, and we will be removing left and including the right pointer inside of this Si, and at each iteration we will be checking whether Pi is equal to Si, right? So that is what we are doing. Let me erase it and let me write it clearly. Okay, wait, this let's not remove, we'll remove this part only. Okay, right, this was G, right? So now let's see. So for this window we saw what Si was looking like. Then what we will do, we will move our left pointer here and our right pointer here. Now what SI will look like? We also saw that, right? We will be including G and we will be removing the C from our SI. Then what we will be doing? We will take our left pointer here and right pointer here. And we will be removing this A from our SI and we will be including H. So again, what will happen? This PI and SI, they will not be equal, right? So if they are not equal, that means that is not an anagram. Similarly, we will keep moving forward and we will reach here. So our L will be here and our right will be here, right? So it will contain 1, 1 and 1 again, and it will be equal to Pi, right? At this point, SI is equal to Pi, so we can say that this is an anagram and we have to include the value at the value of the index that left pointer is pointing to, that is 7. So we will keep doing this until this point and then we will include 12, and this way we will return our answer. So let's code it. Okay, so one edge case that you should be taking care of is that if S size is less than P size, right, then we cannot have any anagram because all the characters inside of P should be present inside of S for it to be an anagram, right? So for that case, we will return an empty array, that is for S. If S dot size is less than P dot size, we will return an empty array. And after this we will write the logic for the sliding window part. So for the sliding window part, what we said, we will be having two arrays, right? Frequency arrays called SI, which will have 26 values, all initialized to 0. And similarly, we will have PI, which will have 26 values, all initialized to 0. So what is this SI and PI for? So PI is to store the frequency of characters appearing in string P, and SI is to store the frequency of character appearing in a particular window size of length of P string, right? So so let's first create. So for creating the very first window, we will be having left pointer and right pointer to 0. So we will create the very first window. So then we will be having, so let's take int left 0 and right is equal to 0. These are our left and right pointers. So to create this window, right, so the first window we will have to create, right? So how will we create the first window? We will have we have to take right to what part? This part, right? Towards 2. That is the length of P is 3 minus 1, right? That is where we have to take it. So here only we will be taking inside of this while loop. What we will say P dot size. The length of this string P is our window size, right? So inside of it, we will be first marking SI and PI, right? So what we'll do, SI will be containing right minus A, right? So we will be marking this as plus, and for PI also we will be having P right minus A plus plus, right? So our PI, and for the very first window we have created this and we'll be incrementing this right pointer. Okay, so after traversing in this while loop, our right pointer will actually contain value that will be equal to P dot size, right? So we have to decrement it by 1 because we should have we should be having right equal to P dot size minus 1 only. So we will decrement it by 1, and then we will be writing the main logic for the sliding window, that is the sliding part, right? First we consider this, then we consider this part, then we consider this part, right? So let's do it. So for that, right should be less than S dot size, right? So when right is less than S dot size, what we will be doing is we will be checking for each and every window if this SI vector is equal to PI or not. If it is equal, then what we will do, okay, we haven't created our answer vector, okay? So we will create our answer vector here, int ans, right? So we will do ans dot pushback, wherever our left pointer is pointing to, we will put it inside of this. Then what we said was we have to remove this particular left from our SI, right, for the next window, and we have to increment the right pointer and include that particular index in our SI. So what we will do, we will say SI S of left, right? This what we will be removing. We will remove this, and we will be including, now we will can increment our left pointer, right? And then what we'll be doing, we will be incrementing our right pointer also. And if our right is not equal to s dot size, right, it should not be equal to s dot size, right, because after right plus plus, when we are at the very end of the string, it can be equal, so we have to avoid that case. So that is why we have this if condition. So if it is not equal to s dot size, what we will be doing, we will be removing, we will be putting the next right character inside of this, right? So what will be the what will be it, it will be si of right, this what will be keeping inside of it. And that is all we have to do. And after doing all of this, we have to simply return our answer, right? So let's quickly run it. Okay, so let's submit it. So it's submitted. So that is how we have to solve this question. So what we'll be doing, we will be creating these frequency vectors for P and for the particular window, and we will be having left and right pointers to increase our window, right? And first we have created, here we have created the first window, and also we have marked all the characters that are present inside of P in this PI frequency array. And then we have taken our answer array, and here we have wrote our sliding window logic. That is, for each and every window we are checking if SI is equal PI, then we will be including the left pointer, and then we have removed the left pointer for the next window size, and we have included the next right pointer for the next window. And doing all this, we have simply returned our answer. So that is how we have to solve this question.